Okay, in this video I'll be talking about special properties of isosceles triangles. Isosceles triangles are triangles in which we have two sides that are congruent to each other, the same length. First of all, let's start with a simple construction. So I just started with one side of a triangle. Okay, that's going to be the base of my triangle, and let's say that I want to construct an isosceles triangle. Well, it's pretty simple. What I'm going to do is I'm going to just take my compass here, and it doesn't really matter what distance I set. It doesn't have to, in other words, I don't have to set it up where like this lands on the opposite point. I can make this whatever length I want to, but if I take this and I draw like a simple arc up here, I know that every point on that arc that I just drew is the same distance from the left side of my base of my triangle. If I repeat this process from the right, so I put it, and I don't change the distance apart on my compass, I don't change the size of the compass, I draw the same arc from the right-hand side, you can see where those lines intersect is going to be the third point of my triangle. And so I can go here, and I know that if the point is here, that means that I am the same distance, because I drew an arc there with the compass, I'm the same distance from the left side of the base of my triangle as I am from the right. So it's going to look something like this. I can even put a little tick mark here, because I know that those lines are exactly the same length. Now they're not necessarily equal to, they're not necessarily equal in length to the base, but they are to each other. Now there are a couple of special properties here. The first being this, that I call these two angles here, this would be the angle across from this side that has the tick mark. This is the angle that's across from this side that has the tick mark. And it just so happens that these two angles are also congruent. We call these the base angles. Okay, so this right here is known as a base angle. The base angles for an isosceles triangle are congruent. Let me zoom in a little bit so you can see that. And there's two base angles, right? Here's the other one. We call this up here, this angle up here, which is not congruent to the other two. It's going to be different probably. We call this angle here the vertex angle. So a little bit of terminology. We have the vertex angle, we have two base angles, and down here this is the base. So you'll see those referred to in like some of the word problems. They'll spell that out and they'll say the base angle is this. Well, that's what they're talking about. It's one of the two congruent angles. The reason I draw this off to the side here is I just want to point out that just because this is on the bottom doesn't necessarily make it the base. Okay? It's the one that's different from the others, right? The base is the one that is different from the others. So on this, even if it's oriented as such, okay, the base angles would be these two guys right here. These would be the two that are equal to each other, that are congruent. The reason being is because they're across from the congruent sides. Okay? So what I would want to do if I'm trying to determine which side is the base here, I would go ahead and I'd flip it like this. I'd rotate the triangle around. Now you can see, yeah, this is definitely the base here, right? This up here would be the vertex. I'll mark it with a V for vertex, right? So let's go on and let's do a few problems. Here are some pretty typical problems that you might see dealing with isosceles triangles. First one, the perimeter of this triangle, triangle ABC, is 68 meters. I want to know how long it is from A to C. So here's what I do in a problem like this. I see that I've got a couple of expressions here for two of the sides, and because of these tick marks, I know that if this is 10x minus 12, this is also 10x minus 12. So that's my first step, is to fill that in. Now, in order to find the perimeter of the rectangle, I know that if I add all three sides together, in this case, they should add up to 68, right? So I'm just going to write a quick algebra expression, 10x minus 12 plus another 10x minus 12 plus the 3x from the base. Those should add up to 68 meters. Now it's just a matter of solving for x. It looks like I have 23 x's. Uh-oh, makes me nervous. Hope I picked good values here. That would be minus 24 is equal to 68. So 23x would be equal to the addition of 68 and 24, which is 92. X is 92 divided by 23, which just so happens to be 4. So with that in mind, if I'm trying to find the distance from A to C, it's 10 times 4, because I'm plugging in 4 for x, 40, minus 12, which is 28, and in this case, meters. Pretty typical problem. Okay, let's do another one. Second example, in this picture below, what is the measure of angle F? Well, shoot, that's not even given to me. So I guess I got to know, first of all, an extra piece of information. Doesn't look like there's much given here. But if I rotate the triangle, make it look like this, right? Now I can see that this is the base. These two angles are the congruent angles. So if this is x minus 9, and I know it's tilted, that means this one here, angle F, has also got to be x minus 9. So I'm going to go through it. Let's tilt this back so it looks like this. This is an x minus 9. And now I can use the triangle sum theorem. I know that the three angles inside this triangle have to add up to 180 degrees. So if I say then x minus 9 plus another x minus 9 plus an x, if I add the three angles together, they should add up to 180. That's 3x minus 18 is equal to 180. So 3x is equal to 198. And x must be 198 divided by 3, which just so happens to be 66. Angle F is 66 degrees. Okay, third problem. Looking right along here. This one, we're asked to just compare side lengths here. And all I want to know is, hold on, I got to adjust my camera. I'm running out of space here. All I want to know is, of these sides, which is longer? Side AC or side CD? Which one is the longer side? And you got to be careful here. It's tough to see, isn't it? Can I zoom in at all? My gosh, that's out of focus. Hold on. There we go. That's much better. Holy cow. All right. On this problem, which side is longer? So here's what I'm going to do here. If I understand the triangle ACD, if I understand that this triangle here, that this is 62 degrees, and this is an isosceles triangle, I know then that this is 62 degrees. Next thing, so that means that for this triangle, what do I have remaining? For the 180 degrees, well, if I've got 180 degrees, and 62 is spoken from angle C, and 62 is spoken of from angle D, that I have 56 degrees remaining. Now, based on the Hinge Theorem, which we learned about in a previous video, based on the Hinge Theorem, a bigger angle results in a bigger opposite side. So if this is 62 degrees and this is only 56, that means that AC has to be longer than this side, C to D. Done with this one. All right. Now I need to compare AB to AD. That's this side to this side. Not drawing a scale. Be careful about this. It'd be easy to say AD is the longer side, wouldn't it? Just based on the drawing. But here's what I know. If I turn this thing sideways, then I would notice, let me move my paper here, I would notice that this is an isosceles triangle, which means these two angles here have to be congruent to each other, right? And I also know that these three add up to 180. So if I take 180 and I subtract the 62 out, that means I have 118 degrees remaining between these two angles. But they're the same. So I'm going to divide 118 by 2, and I can figure out that each of these must be 59 degrees. There's my three numbers that add up to 180 degrees. Well, then according to the Hinge theorem, once again, a 59 degree angle is going to produce a smaller side over here than a 62 degree angle is going to produce over here. So if I'm going to compare then AB to AD, that tells me then that this side here across from the 59 is smaller than the side across from the 62. AB must be smaller than AD. All right, last problem. This video is getting long, so I apologize. I should have maybe created two different videos. Last problem. What's the perimeter of this triangle? Well, that seems weird, right? I mean, I know that I'm going to take the three sides and add them up, but the problem is I don't know what X stands for, right? So that's my job here, is I got to figure out what X stands for. Well, here's what I know. The tick mark says that those two sides are equal. So if I go and I take x squared and set it equal to 5x plus 6, maybe I can figure out what x is. Now, this is an x squared problem. We've done a lot of these in our class. Step 1 is to set this equal to 0, so I move everything to the left-hand side. x squared minus 5x minus 6 is equal to 0. So I subtracted this to the left and this to the left. That's a factoring problem. If I factor this, I need two numbers that add to negative 5 that multiply to negative 6. I'm thinking like a negative 2. Oh, no, not negative 2 and negative 3. That would multiply to positive 6. How about negative 6 and positive 1? If I factor this out, I get x minus 6, x plus 1 is equal to 0. That means, because of the zero product property, that either x minus 6 is equal to 0 or x plus 1 is equal to 0. So my two solutions here, x could be either 6 or x could be negative 1. So let's go back up here. Does 6 give us an answer that we want? If this is a 6, that means 6 squared is 36 for this side. And if this is a 6, that means this is 5 times 6, which is 30, plus another 6. Oh yeah, it's 36 as well, right? Aren't they the same? So the perimeter is 36 plus 36 plus 25, and if I add those together, I get 97. But the problem is I don't know that it's 97. What if x was negative 1? What happens there? Well, if x is negative 1, if I take negative 1 times itself, negative 1, I get positive 1. If I take 5 times negative 1, that's negative 5, plus 6 gives me, 1 again, of course, they're the same length. So it could be that those are 1, 1, and 25, which gives me a perimeter of 27. And the problem with this, the issue is I really don't know which one it is. So I have two possible answers. The perimeter could be 91, it could be 97, or it could be 27. That's a more advanced problem, definitely. But that gives you an idea of a few problems that you might see in a typical